Now we are going to see area of triangle formula. Okay, this we have done already. Basically, this formula, everyone is known with this formula, Herons formula, for the area of triangle, for especially for the skeleton triangle, where we don't know about the sides and we don't know about the angles. Basically, what is the relation between the angles, or what are the angles given? Because if we know isosceles triangle and equilateral triangle and right angle triangle, so it will be easier for us to find the area. But if we don't know about the angles, actually if we don't know about the triangle, is it a right angle, isosceles, or equilateral, that is called skeleton triangle. For the skeleton triangle, we have to use the Herons formula. So what are the things we have in Herons formula? Here we have, as you can see, here I have S. What is S? Basically, S is nothing but a semi perimeter. It is a plus b plus c by 2, the sum of all three sides divided by 2. So let me draw one triangle. So I'm drawing the skeleton triangle. This is my skeleton triangle. This is A, this is B, and this is C. Okay, now, okay, I'm driving this formula because normally I think mostly students, they are very well aware with this formula, but they don't know from where this formula came. So I just want to give you the knowledge for this formula, basically from where, so that it will be easier for you to understand how to drive this formula from a triangle. So see, this is my skeleton triangle, and what I'll do is I'll draw one perpendicular bisector here. But since it is not a equilateral triangle or something, we cannot say perpendicular bisector. It's just a perpendicular here, or drawn on a side BC from A, and the point is given as D. Okay, as we are discussing the skeleton triangle, so now side BC is represented by A, opposite of angle A, and side AC represented by B, small b, opposite of angle B, and side AB is represented by small c, okay, which is nothing but AB. Okay, so what we have here is, now we have to prove this formula. How to prove this formula? See, there's a simple thing, only we have to use a Pythagoras theorem. Okay, but how to use that? Why? See, why I have taken this perpendicular bisector here to use the Pythagoras theorem. That's the most important part. But not just Pythagoras theorem, probably we have to use here some sine and cosine rule. Okay, let's see what will happen. So what I have here is two triangles, since I have taken a perpendicular here on BC, so because of that ABC is divided into two triangles. One is ABD and one is ADC. Okay, so from ABD I can say that my AD square, I'll write here in a triangle ABD. If I'll use a Pythagoras here, so my AD square is equal to nothing but AB square minus BD square. Okay, what is my AB? Is nothing but C, so AD square is nothing but C square minus BD square. I'll give this equation as name 1. Now what we have here is this triangle. In this triangle, what we have, another triangle ADC. So in triangle ADC, now from ADC again we'll use the Pythagoras here. So what will happen? AC square is nothing but AD square plus CD square. So AC square is equal to AD square plus CD square. Just now we got AD square, okay, from the triangle ABD. So with that AD square we can use in this second equation. So I'll write this as AC square, and I'm substituting this value here. Okay, so what I'll get is C square minus BD square plus CD square. Okay, C square minus BD square plus CD. Since my BC is equal to A, CD can be written as A minus of, if I can write CD here, it is nothing but A minus BD. So I'm writing CD as nothing but A minus BD square. If I'll open it, so what I'll get is AC square is equal to nothing but C square minus BD square plus A square. I'm gonna open here as A minus B whole square formula. So A square plus BD square minus of 2A BD. You can see here BD BD will be cancelled out. Now what is left? AC square is equal to C square. What else we have here? C square plus A square minus 2ABD. So C square plus A square minus 2ABD. This is what we got from this. AC square is nothing but from the triangle you can see that is B. So I can write this as B square is nothing but equal to C square plus A square minus 2ABD. Okay, as you can see, now I will bring this term to this side, this 2ABD terms to left hand side, 2ABD, and I'll bring my B square to the right hand side, so C square plus A square minus B square. Okay, and since we can see here my ABD, so I can write this BD as nothing but C square plus A square minus B square divided by 2A. Now this is what I got BD. Now this BD I can substitute in my equation 1. Where is my equation 1? Here is my equation 1, C square minus BD square. Okay, so I'll substitute this BD in the equation 1. So what I'll get is AD square is nothing but C square minus of C square plus A square minus of B square whole square divided by 2A. This 2A comes under the whole square only. Now I'll just solve this problem. Okay, this to solve this equation. So C square minus of C square plus A square minus of B square whole square and divided by, I can just taking 2A out of the square, so I can write as 4A square, and I'll take the LCM now. So I'll get this as 4A square C square minus of C square plus A square minus B square whole square divided by 4A square. Now this 4A square C square can be written as 2AC whole square and minus of C square plus B square, C square plus A square minus B square whole square divided by 4A square. Now AD square is nothing but equal to, now see, if you see this thing, 2AC whole square minus C square plus A square minus B square, it is nothing but formula of x square minus y square, means x plus A minus y plus A, x plus y or x plus y or x minus y. We can write this like, it is nothing but a formula of x square minus y square, which means x minus y and x plus y. So I'm opening like that only. So 2AC plus C square plus A square minus B square into 2AC minus C square minus A square plus B square, and divided by what we have here already, it's nothing but 4A square. Okay, now what I'm going to do here is AD square is nothing but equal to, now see, A square plus B square, A square plus C square plus 2AC can be written as A plus C whole square minus of B square, and in this term, if I'll take minus common out, what I'll get is here that B square minus of A minus C whole square divided by, I have 4A square. Now AD square, now again A plus C whole square minus B square, we can open this as a formula of a x square minus y square, means x minus y and x plus y. So I'll write this as A plus C minus B, A plus B plus C, and this one I can write as B minus of A plus C. Okay, and this one we can write as B plus of A minus C divided by 4A square. Okay, now what we got here is something related to A plus B plus C and A plus C minus B. We know already S is semi-perimeter is nothing but A plus B plus C divided by 2. We can write this also as a plus b plus c is equal to 2s. So from this I'm going to write few equations. So 2s is can be written as a plus b plus c, and also in the first part you can see that a plus c minus b. So a plus c I will find out from this. So a plus c can be written as nothing but 2s minus b is equal to a plus c. Okay, this is one result we can say that from the perimeter. And also we can write as b plus c. B plus c will be nothing but 2 minus a, that is b plus c. This will be second result. And also we have a plus b, that is 2s minus c is nothing but a plus b. Just substitute this value, so you will get ad square nothing but 2s minus 2b 2s 2s minus 2a and 2s minus 2c whole divided by 4a square. So finally my ad square comes as, if I'll take 2 common out, so definitely my 4 will be cancelled out with this 2. So I'll get 2 into s minus a, s minus b and s minus c. Okay, if I'll take ad under root of this whole thing, so this thing comes as under root of, here we have 2 and divided by a square. Now what we have there is, now we got ad we got something as nothing but 2 under root of s minus a, s minus b, s minus c into s whole divided by a. So we have to find the area of triangle ABC. That will be nothing but half into base into height. Base is BC, height is AD. So when we substitute these values, a into 2 by a into under root of s into s minus a. So what we got, a gone, 2 gone. So we got this as s into s minus a, s minus b and s minus c. This is my area of the triangle ABC. Okay.